All right, forensics people, welcome back to the part 2 of our over-the-counter drug lab. So this part is very similar to the first part. We're going to do the same types of procedures on the material, but we have three antacids. We have Alka-Seltzer, we have what's called a complete controller, and we have what's called a generic antacid tablet. So these are like ones where you go to the store, they're in like the Tums-like dispenser. They are in that category of acid relief. So it is a Tums analog. So when we say generic, it means that it's the same contents of what's in Tums, except it's just made by whichever company you're shopping at. So like Care One if you're Hannaford, and generic Rite Aid or Walgreens, whatever the generic one. Great Value if you're at Walmart. Okay, so we have the 3 columns for the known, and we have 3 unknowns that you're going to choose from. So what I'm going to do, because they end up adding up to 6, I'm going to do it all in one plate. And there's either unknown B, unknown G, or unknown H. There's only 3 unknowns because there's only 3 of these. And so now, because of that, guys, in this column, this will be unknown B when I go to record data. This will be G, and this will be H. And I'll do them side by side. I'm going to load up all the wells. Probably should have loaded the wells up prior to showing this to you. And so column 1 will be Alka-Seltzer. This will be the acid controller. This will be generic. Then this will be B, G, and H on the plate that I'm going to use. So I'm going to see if I can write it on there. I just really washed it really well. I tried to make this video just right before this, and it ended up, there must have been something stuck in the wells from other experiments because it didn't work well. When I got down to the very bottom, it was very strange results. And so this plate was washed really well. It's been rinsed out. And I noticed it still looks like there's stuff on the bottom of one of these wells. Yep. Even though I really, really washed it out with a scrub brush and everything. So we're going to say that this is Alka-Seltzer. So this is, I'm going to put down AS for this. Oh, it's not going to write, is it? That's Alka-Seltzer. This is complete. This is generic, GEN. This is for me, so I know I'm putting this stuff in the right place. B, G, and unknown H. Okay. So I know it's kind of hard for you to see that against the black background. Now, on your data table, which is page, what is that, 52? 52. Okay, so we're on the back side of what we used the last class. We're going to take this just like before. We're going to take it and we're going to just divide this all the way across. And I'm going to use these 2 last cells. Oh, I didn't do that very well. That's okay. I'm going to do it individually now because I think I do it better if I do it this way. Right, so the top part is going to be the description. The bottom part is going to be the solubility. Okay, so you know we're splitting it. A on the top, B on the bottom. I'll probably have to go over the line there. Here, we are going to use universal on the top, and on the bottom it's pH paper. Okay, now on this one, we're going to do 2 things. We're going to, how does it react? And what's the pH? And we're going to test this over time. Just because I know there's a question that says, over time, which one is the better buffering agent? Which means resists changes to pH. Okay, so when we look at these antacid things that we're trying to resist changes to pH. Okay, we're going to add an acid in there, and then we got to see, oh, why are you doing that? How it resists changes. So the Alka-Seltzer, I'm going to show you what it looks like, and then I'm going to save it for people who do it in class, because I've already pulverized some. It's a very large tablet. It feels gritty on the outside. It's embossed with the name. So this is why if you're in class doing this, they don't get to see that. I already give it to them ground up as an unknown. They don't get to read the tablet. Okay, so I'm going to put down embossed. It feels gritty on the outside. It's off-white. And when we pulverize it, it powders easily. And I gotta say, all of these are very easily crushed. It's not like in the other one. So my observations, and you should be listening to me as I do this, is that it feels kind of gritty to the touch, not like the ibuprofen that was slick and hard on the outside. So when I crush it, this is what it looks like. This is the Alka-Seltzer all crushed. I get a lot out of the tablet. When I look at the acid controller that's complete, it's a colored tablet. Again, it's got the embossing on it. Now, these colors can vary. They can be red, they can be green, they can be, I'm trying to smell it. There's no flavor smell, but that's because it's been out so long in the lab. Sometimes they smell like fruit. So this is orange in color, or orange in color. Again, it has that like chalky feel to it in your hands. It's round or circular. It is easy to pulverize. But it keeps the color when it's pulverized. It doesn't disappear. So this is that material pulverized. I'm going to try to scrape it off the sides and get some more. Because I pulverized it before, and I tried to do the experiment. Like I said, there must have been something in the wells. And the last one, I might have to repulverize this. I don't get a lot for this. The generic one makes really fine powder, and it's small to begin with. So this is smallest in size. It's not as chalky on the outside. It's more firm or more smooth on the outside. It's definitely off-white. If you look at it, it looks like the color of the porcelain dish there. It's not the color of the paper. And it gets fine powder when you crush it compared to the other two. And let's see, hopefully I got enough to do what I need to do. And then I have the 3 unknowns. And again, the 3 unknowns are already pulverized. So let's hope that I can get these into my little wells. And I'm going to use this unknown. This is unknown B. Unknown B looks like it's an off-white powder. Like even Alka-Seltzer looks a little off-white. It's pretty fine. If I look at G, well, this one's colored. This one actually is like a raspberry color. Everything getting stuck over here. So this is raspberry. It's not as fine and flaky as the other one, but it's still small powdery. It's a little bit, what's the word? It's like it gained water and it's a little chunky. And then H looks off-white. Almost looks like a fine powder. Because it's already broken up. So I'm going to take, and because I have H in my hand, I'm going to scoop it down. I hope I can scoop it down. One in there. What I'm going to do on the one where you add acid, I'm going to put a little extra in there, guys, because sometimes when you add the acid, so I'm going to try to get like 4 equal scoops. Maybe I do, well, I got enough H. I'll see what happens with the generic. One and the best one. So that's H. Let's do G. This is my G1. So I'm actually going to flip this over here for a second, because we got to get the powders in order for you to see solubility. So I'm going to work this way, right to left, so I'm not hanging out over another powder. I might have to open another vessel because I already took like 4 big scoops out of this one from before, so I'm kind of getting down low. There's 3. There's 4. I like my little mini scoops. Tiny scoopulars for doing tiny amount of work. So now I have to B. If you want to fast forward me scooping out, you can do so. And my hands are busy, so I'm not pausing. Just going to have enough here. And I just got to get some in the last one. Okay, so I'm going to pause it and then resume once I have everything scooped out. Okay, so they're all scooped out. You can see there's a slight orange tint to this one. If I tilt it, you might be able to see the pink tint on that one. See how they're a little different in color? But again, that has to do with flavor. I am going to add water to these. You can always pause at any time if you want to describe something you see. Oh, look, bubbling as soon as I add water. So the Alka-Seltzer bubbles as soon as I add water. And what I'm going to actually do, guys, because it works better on these, I'm actually going to add a little bit of water to every well, even though we didn't do that in the pain reliever. A lot of it has to do with how, look, this is bubbling too. Not as much as that one, so this might be, but it's bubbling. Interesting. Well, there's a lot of Alka-Seltzer in there, so that's why it's bubbling so much. I'm adding just a little bit to wet it on the bottom, so when I add the acid, some of it's dissolved, and it can react with the stomach acid. I'm going to just put, again, just a little bit to get the material dissolved, just a little, so when I add the chemical to react, we can see how it reacts. Okay, so Alka-Seltzer definitely dissolves. That is dissolved. And look, so is H. It's disappeared. So this is very soluble, and H is very soluble. Now, the complete is cloudy, so it's slightly soluble. And there's still stuff on the bottom, and that could just be the amount that I have for the water that's there. Oh, that was good. Good thing I have my goggles on. Wow. Now this smells like orange. And this smells like mint. Now that there's water there, I'm like, whoa. That one also kind of smells minty. Let's see what this one smells like, if I can get a whiff of it. This, I can smell the orange being right over it. Okay, these are all partially soluble. This is very soluble. It disappears. Partially, because it's cloudy. This is partial, because it's cloudy. And this has that slight orange tint to it because of the color of the material. Again, partial. This is cloudy. Again, you're choosing one of them. You don't have to fill in the whole thing. Choose one of these and put it in this column as your unknown. And your unknown column is that one. I'm doing all 3, so you get a choice. But this is very soluble. So if I was like someone who's like a guessing person and wagering person, I would look at my top results there, and I'd look at Alka-Seltzer and column for H unknown, and they're behaving very similar to each other right now. Yeah, this smells like cherry-ish, like a berry now. So this smells like berry. Couldn't smell it before, mainly because they're so old, and this smells like orange. The other two smell a little minty. Yeah, oh boy, both of these are mint. I'm going to put down a mint odor. Okay. If you need to write down the observations, you can pause it. I'm going to keep going, so I try to get this in before the bell rings. Taking pHs. I'm going to first do the pH paper, so I'm going to stick a pH paper in each one, and then I'll pull it out. And I just rip it in half because I don't need a really large pH paper. Well, that looks like it's a 7 or an 8. That's definitely a 7 because it's yellow. And then I'll pull them out and we'll see what they are, and then we'll put the other things in. Oh, these are all kind of high compared to the other ones that we did previously. Where did I put my thing? Okay, so this one, pull it out. That's definitely like a 7. I'm going to say the first one is a 7. And just because these seem to be behaving correctly, this is really hard with goggles on because the light is not passing through. But since I'm not going to add chemicals right now, I'm just looking at this. This is also a 7. Okay, so the two that I pulled out is this one and this one all the way on the other end. To me, they are both 7s. Let me look at this one. Oh, it's even changing color with it in it. 8.5. Not quite an 9. It's not quite that green. I'm going to go with an 8.5 on this one. This one's more like an 8. You might even say, well, maybe it's a 7.5, but I'm going to go with an 8. That's kind of like the one I just pulled out. Even similar color distribution. I'll go with an 8. This one is weird because it's got the pink on the bottom and lighter green on the top. And I think it's because of the color, the coloration. So this to me is like in between. I'm going to go with an 8.5 on this one. So let's look what happens when we add in the universal indicator. I'm going to put a couple of drops because it depends on concentration, what vividness you get for the color. Really, 1 drop should be enough. But these two with like background color to it, it's going to mess up our reading. Ooh, look, these two, they look like 7s. Where's my little color chart? So they're green. That really looks like a 7, right? To 2 ends. So the color here is green. That's definitely green. This is definitely green. Right, so I know it's hard to see because I zoomed in. So the 2 ends are green. This one and this one. I have to stop writing, otherwise I'll never focus. That's a 7 on the chart, and that's a 7 on the chart. This to me almost looks like a blue color. So if I look at that pH to me, and this is hard because it's not purple. This one looks a little purple because of the pink that's there. I think this is blue. So I think this is a 9. Oh, not this one. I'm sorry, guys. It's this one. These are what I call teal. Kind of, because it's in between a green and a blue. So that's looking like a pH of 8. I think that's close to the pH of 8. So they're kind of agreeing. These are a little higher than what I got off of the pH paper. All right, now I got to get my pH paper ready. Okay. We're going to add acid. Now, some of these are going to bubble when we add the acid. That one's bubbling. I'm trying to keep the number of drops of acid the same between wells. So I'm just going to do this. It will mix it a little. This bubbled. That one really bubbled. This had a small amount of bubbling. These two did not bubble when I added the acid. Okay, so the Alka-Seltzer, no bubbles. It bubbled when you dissolved it. Oh, this I should put in here bubbled up here. Same thing, this one bubbled. Like really bubbled just by adding water. Okay, now C, no bubbles. This had bubbles. This had tiny bubbles. So it didn't really fizz. This one also had a tiny bubble. This one bubbled. This one had no bubbles. Okay, now we have to check pH. And this is the one which is kind of weird because we have to check it and then we're going to let it sit and then we're going to do our next experiment and we'll check it again. So check the pH. Ooh, that hasn't changed much. That's a 6. Okay, so Alka-Seltzer is a 6. That's pretty good. pH didn't change much. Oh, this is definitely lower than a 6. That's like a 5. Yeah, it's actually in between a 4 and a 5. I'm going to go with 5 and be kind of giving. That changed a lot. It went from 8.5 to down to 5. So that did not buffer very well. Supposed to get rid of the acid. This didn't do a good job. Oh, that's horrible. That's acidic. Like really acidic. 3? Oh, that was bad. What's the next one? It's got a little red hue to it, but not like the 3. I'm going to go with a 4 on this one. That one didn't do too well either. All right, let's see if my prediction on this one, well, it's going to be like that well. So let's see if it's around 5. Now, the thing that I hate about it is it's got that stupid pink color in it. No, this looks like it's a 4, 3, and I got to tell you guys, it's really hard for me to figure out if the pink known color is, I'm picking up the pink of the tablet, or if it's a pH. I'm going to go with 3.5 on this one. But this one's tough because this might be picking up the color of the tablet. And then we have one more. And I'm going to let it sit, let them sit for a while, and I'll retest them. Oh, this one looks like it's a 7. It's 6.5, 7. Not quite 7. But it's like 6.5. This one, on the end, and the Alka-Seltzer changed the least. This changed a lot. That changed an awful lot. So these are horrible antacids. No, it's not worth even taking them. All right, let's do our last reaction, and then I'll come back and retest. I don't see much. Oh, that one. Oh, it cleared up, though. That's interesting. This stayed yellow. This had a quick turn to brown and then go back to yellow. This is yellow. This is yellow. These are hard to tell because they have the stupid color in. So what I'm going to do is I'm going to put an extra drop going across. So this isn't quite acting like that. I'm not sure why and what's making a difference there because right along, to me, boy, that H sure seems like Alka-Seltzer. And stir, light yellow. I wonder if it's like a different batch or something. Okay, this sort of has a brownish yellow color to it, but because of that orange pill, it's really hard for me to tell. This guy's staying yellow. There's just a lot of powder in there. And see, because they don't dissolve well, it's not as bright yellow as this. So I'm going to call this an orange yellow. Oh, wow, I can really smell that synthetic mint smell. Yeah, this is like an orange yellow also. The pink is masking it, but that is a yellow underneath there. And this one is a clear, but an orange yellow. See, these aren't dissolving. These two dissolve. Ooh, I'm making a mess. So let's look at the bottom. This stayed yellow. And I'm going to put clear because it means that stuff dissolves. This was cloudy, and I'm going to do an orange yellow or orange yellow, depending on how you want to pronounce it. This is the same type of thing. I'll go with the same description. It's cloudy. I'm going to use the term ruddy because it almost has a brown hue to it. I think it's because it was pink to start with. And this is clear, but it's like a brownish yellow. It's not as bright as the first one. So now I'm just going to do a quick thing here. I'm going to use the universal indicator because it's the last test, and I'm just going to retest the pH while they've been sitting there of the one with the acid to see if there's a lot of change over time. That is still neutral. That's still a little basic. That's interesting because on the pH paper it doesn't come out that way. I'm going to go back because I hate the ones that have the color powder in it. You can tell that this one, the middle one, this generic, really horrible at modifying the pH of the acid because it is red. And that redness, even if I dissolve more, that redness is indicating that does not buffer very well. This stays kind of on the green side, so it's buffering well. That one stays on the green side, it's buffering well. This is slightly pink, but again, you might look at it and say, geez, no, it's looking like it's more 7 with the indicator rather than the pH paper. So, but these still change pH compared to the ones on these two. They don't change a lot. You're looking here to here. That pH is really close. I added acid to this one doesn't have acid. So the H is good at keeping the pH the same, and so is Alka-Seltzer. This changed. This went from a dark blue to a teal. Dark blue to, gosh, who knows what that is, right? And this almost went to an orangey yellow. So that's way down at a pH below 4 or around 4, okay, which is what we said with the pH paper. So even as time goes on, these two are not losing their ability to keep that pH the same.